I want you to run a little simulation in your head for a moment.
Okay.
Picture yourself as a Java developer. It is, let's say, 2015.
Right. Dark times.
Exactly. So you sit down at your desk, you've got your coffee in hand, maybe it's a dark roast, piping hot. You crack your knuckles, put on your headphones, and you just sort of enter the flow state.
The zone.
The zone, the world just melts away. And for 6 solid hours, you are writing code, you're building out these complex class hierarchies, you're defining interfaces, crafting all the business logic. You are just doing beautiful work.
I can almost hear the keyboard clack from here. It's that really satisfying mechanical keyboard sound.
Right. It is rhythmic. And then at the end of the day, you compile it. You get that binary file, the executable app.jar. You check that binary into GitHub so it is safe.
Yep, standard procedure.
And here's the twist. You highlight every single line of source code you just wrote, the .java files, the logic, the comments, literally everything, and you hit delete. Gone. Forever.
That is physically painful to even imagine. You'd be fired before you even finish your coffee the next morning.
Oh, absolutely.
That is just professional suicide.
It sounds clinically insane. But here's the reality check, and this comes straight from Sean Grove. That is exactly how most of us have been using AI for the last 3 years.
Yeah.
We chat for hours. We refine, we argue, we kind of vibe with the bot. We finally get that one code snippet that works. We paste it into our IDE, and then we just close the tab.
We throw it away.
We throw away the conversation. We completely throw away the context.
You know, it's the perfect analogy.
Yeah.
Because in this new paradigm, the conversation, the prompt history, the back and forth, that is the source code. That's where the actual intent lives.
Exactly.
The actual code that the AI spits out, that is just a compilation artifact. It's the binary.
Yeah.
If you delete the context, you have fundamentally lost the software. You've lost the entire why behind the what.
And that is exactly what we are unpacking today. We are moving past this era of vibe coding, where we just sort of poke the black box until it does something cool. We are learning why the context is actually the new code.
And perhaps more importantly, why if you aren't strictly rigorously engineering that context, you aren't really building software anymore. You're just rolling a very expensive pair of dice and hoping for double sixes.
Welcome.
This is AI Deep Dive, coming to you live from the turning point of history at Beskar. Stay tuned for a bulletin from tomorrow.
Welcome to AI Deep Dive with Beskar.
Glad to be here.
Now, looking at the calendar, it is March 2nd, 2026. This is our 3rd show, but it feels, it feels heavier. It feels like a real milestone.
It does.
We're putting aside the general news cycle today to dedicate this entire session to a single, meaty, highly technical discipline. This is our very first true deep dive.
And it's necessary. The industry has really shifted under our feet. The novelty of, oh, look at it, wrote a poem or made a funny picture, that's dead.
Very dead.
We're in the engineering phase now. We need to drill down into the actual mechanics of how we work with these systems at scale.
Right. And because this is a totally new format for us, going really long and really deep, we need you, the listener, to be our feedback loop here. Jump into the comments or the community Discord. Let us know if this level of granular detail is actually what you're looking for. But orient us here. What is the overarching mission for this deep dive?
So we are tackling context engineering.
Yep.
And I want to draw a very sharp line in the sand right now. This is not prompt engineering.
Right.
Prompt engineering was 2024.
Yeah.
That was figuring out how to ask the model nicely or saying, please act as a senior developer.
Or I will tip you $20 if you get this right. I remember those days.
Right, the whole bribery phase. We were treating the AI like this capricious genie. That's the old way.
Yeah.
Context engineering is totally different. We were talking about the systematic architectural design of the information environment for AI agent.
Okay, so what are we pulling from today to build this picture?
We are pulling from a massive stack of sources today. We've got internal talks from YC's Dex Horthy. We have technical breakdowns from Anthropic's Barry Zhang, and some very dense, fascinating papers from ArcSiva on Context Engineering 2.0.
Plus some really critical analysis from Mart Vanderjagt and the research team over at dbrinig.com. It is a stack that frankly changed how I look at my own chat history entirely. I used to just see it as a log file. Now I see it as, well, let's just get straight into the definition.
Let's do it.
The paper from ArcSiva uses a phrase that really stopped me in my tracks. They define context engineering as entropy reduction.
It's such a fantastic framing. It sounds incredibly academic, but it's actually super practical.
But it's also a physics term. Usually when I hear entropy, I think of thermodynamics, the heat death of the universe, things falling apart into chaos. What does entropy have to do with my coding assistant?
So you really have to look at this through the lens of information theory.
Like Claude Shannon.
Exactly like Claude Shannon style. Think about human thought. Think about the way you and I are literally talking right now. It is high entropy,
Meaning it's chaotic, unpredictable.
meaning it's ambiguous. It relies on a million shared cultural assumptions, facial expressions, tone of voice, inside jokes. We say, you know what I mean? And usually the other person does.
Yeah, because of the shared context.
Right? It's rich, but it is incredibly messy. To machine, to silicon-based intelligence, that high entropy is just pure noise. Machines crave low entropy. They need structure. They need precision. They need explicitly defined constraints.
So the machine effectively speaks a totally different cognitive language. We speak in vibes and implications, and they speak in strict logic.
Precisely. The RTIQ paper argues that context engineering is the bridge, is the active, deliberate process of taking that high-entropy human intent, like saying, I want to build a cool website that feels like 1990s GeoCities, and filtering it down, compressing it, and structuring it into a low-entropy format that the machine can actually execute without guessing.
So it's essentially a translation layer. You're taking the fuzziness of the human brain and crystallizing it.
It is. And they make this point that I found absolutely fascinating. This isn't actually a new concept. If you go back to the 90s, to what they call Era 1.0, the graphical user interface, the UI was just context engineering.
Wait, dragging a file into a folder is context engineering. That seems like a bit of a stretch.
But think about it. You have this chaotic human desire. I want to save this picture so I don't lose it. That's the intent. It's vague. The GUI forces you to click a specific icon, select a specific directory path, and hit a button labeled Save.
Oh, I see.
It forces you to reduce the entropy of your intent into a very specific command sequence that the computer understands. You couldn't just yell at Windows 95, hey, save this document.
I mean, you could, but it wouldn't do much except maybe annoy the person in the cubicle next to you.
Exactly. The GUI was the constraint. It forced you to speak the computer's language. But now, in Era 2.0, we are dealing with LLMs as what they call initiative agents. The input isn't a rigid mouse click anymore. It is natural language. But the underlying goal is identical. We have to minimize that cognitive gap between carbon-based intelligence and silicon-based intelligence.
That really clicks for me. So when I spend 20 minutes organizing my project files or writing out a strict rules document for my AI, I'm not just doing admin work. I am essentially doing the exact same job a UI designer did 30 years ago. I'm building the interface.
You are designing the operating constraints. You are defining the sandbox. And Dex Horthy makes a crucial point that connects right here. He reminds us that, strictly speaking, LLMs are pure functions.
Pure functions. Now, for the non-computer scientists listening, we probably need to define that clearly.
Yeah. So in computer science, a pure function is a function where the output is determined only by the input. It has absolutely no side effects. It has no hidden state. It doesn't remember yesterday unless you physically feed yesterday's data back into it as an input today.
Right.
Function of x equals y. If x is the same, y is always exactly the same.
Because the AI doesn't have a personality, it doesn't have a mood, it doesn't hold a grudge because I was rude to it last Tuesday.
There is no ghost in the machine. Dex argues that for an LLM, the only thing that determines the quality of the output is the quality of the input, the context window.
That is sort of terrifying and liberating at the same time.
It really is. Because it puts the responsibility squarely on us. I mean, if the output is garbage, it's not because the AI is having a bad day or because the model is inherently stupid. It's because the context was garbage.
Garbage in, garbage out.
But applied on a massive semantic scale.
Okay, so if the context is the code, and the context is the only thing that matters, we really need to talk about how we're messing it up. Because looking at the research from debrunig.com and Mart Vandriacht, it seems like we are messing it up in some very specific, very preventable ways. They list some terms that honestly sound like medical diseases: context poisoning and context clash.
Yeah, these are the failure modes of long contexts. And this is vital to understand because the marketing hype right now is all about size.
Oh, totally.
We have a 100,000 token window. We have 1 million tokens, 2 million tokens, and we naturally think, great, I'll just dump the entire documentation PDF in there, throw in my whole code base, and let it figure it out.
I am 100% guilty of this. Here is the entire backend. Fix this weird routing bug. It feels efficient.
It feels efficient, but it's incredibly dangerous. That is exactly where context poisoning kills you.
How so?
The example they cite is from the Gemini 2.5 technical report. They had an agent playing Pokemon.
Wait, hold on. An AI playing Pokemon, like actually playing the video game.
Yeah, Pokemon Red version running on a Game Boy emulator. The AI is playing, exploring the map, fighting trainers, reading the screen states. And at one point, it hallucinates.
Naturally.
Right. It makes up a game state. It thinks it found a specific item, let's say a master ball, that it didn't actually find. But, and here's the poison, that hallucination got saved into the context history.
Oh, no. It wrote down a lie in its own diary.
Exactly. So 10 turns later, the agent looks back at its quote-unquote memory, which is just the context window, sees this hallucination, treats it as a hard factual premise, and starts making plans based on it. I will use the master ball to catch Mewtwo.
It became totally fixated on an impossible goal because the well had been poisoned early on.
It believed its own lie because the lie was literally indistinguishable from the truth once it was inside the context window. And once it's in there, it acts like a virus. It infects all future reasoning. That's poisoning.
That is wild. And then you have context distraction, which is what it just gets bored of the task.
In a way, yes. The research shows that the more history you have, the more the model relies on that specific history rather than its core foundational training. It gets lazy.
Give me an example of that.
Sure. Let's say you've been writing messy, quick and dirty script code for the last 50 turns in a chat. The model looks at that massive block of context and thinks, oh, we're writing messy code today. And it deliberately degrades its performance to match your current vibe.
Wow, that explains so much. I have physically felt that degradation. I start a session in the morning, the bot is brilliant. 2 hours later, it's making basic syntax errors and forgetting variable names. I honestly thought the servers were just under heavy load or something.
Nope. It's not getting stupider, it's getting more like the context. It is overfitting to the immediate conversation.
Yeah, he's wild.
Then there is context confusion. This is the good one.
Mm-hmm.
Drunig highlights a study on tool use. They found that Llama 3.1 fails significantly when you give it 46 tools, but it succeeds when you give it only 19.
So choice paralysis is real for AIs too.
Absolutely. If you dump every possible API endpoint into the context, the model just gets confused about which one to use. It's pure noise. It is high entropy. It starts hallucinating parameters because it's completely overwhelmed by the options.
And context clash. This one sounded particularly interesting to me.
This one's fascinating because it goes completely against how we naturally converse. This comes from a joint study by Microsoft and Salesforce. They looked at sharded prompts versus single prompts.
Sharded meaning broken up into pieces.
Right. Basically, is it better to drip feed information to the AI over a conversation or give it one massive block of text at the very start?
Well, intuition says drip feed, let's have a conversation. Let me ease you into the problem space so you don't get overwhelmed.
And human intuition is totally wrong here. They found that when you drip feed, when you have a long back and forth conversation, introducing requirements one by one performance dropped by 39%.
39%. That is a massive drop. That's the difference between a working application and a total crash.
It is huge. And the underlying reason is context clash.
How does that happen?
When you drip feed, the model is constantly making early assumptions. You say, hey, I want to build a modern website. The model thinks, okay, modern website, probably React. It generates a bunch of internal reasoning based on React. Later in the chat, you say, oh, by the way, I want to use Vue. Now you have a context window that contains both the strong assumption of React and the correction of Vue. The model has to fight its own previous output. It's a latent state conflict.
Whereas if I just said I want a Vue website at the very beginning.
No clash. Clean context, low entropy. You haven't confused the model with its own past assumptions.
This brings us right back to what Dexhorthy was saying. If dumping everything into a million-token window is a trap because of poisoning and distraction, and drip feeding is a trap because of clash, what on earth are we supposed to do?
Well, he suggests intentional compaction.
No, to me, that sounds like I'm taking my code to the junkyard to be crushed into a cube.
It's a great visual, but think of it more like a rigorous distillation process, or like packing for a backpacking trip. You don't bring your entire closet. You bring exactly what you need to survive. Dex's approach, and this is what they actually use at Human Layer for their enterprise agents, is about keeping the context utilization strictly between 40 and 60%.
Never let it fill up.
Never.
But that seems so counterintuitive when the hardware companies are selling us these massive context windows. Why pay for a mansion and only live in one room?
Because the rest of the mansion is haunted. Remember the distraction and the poisoning we just talked about. You want the context to be incredibly fresh, perfectly relevant, and highly accurate.
Okay, that makes sense.
Dex calls the naive method, the one we all default to, shouting at the AI. You know the drill?
Oh, I know the drill. No, do this. No, stop. You're doing it wrong. Fix line 40.
Exactly. You do that until you run out of tokens or you literally start crying.
I have absolutely cried at a chatbot before. I'm not afraid to admit it. It is a very unique kind of modern despair when you are furiously arguing with a machine that is endlessly apologizing to you while making the exact same syntax error for the 5th time.
We all have. It's maddening. Dex says that emotional reactive cycle is a total anti-pattern. Instead, he proposes a very structured workflow. Research, plan, implement.
Walk us through that. How is that fundamentally different from just opening a chat window and talking?
Okay, so step 1 is research. You do not ask the AI to write a single line of code yet. You ask it to thoroughly understand the code base. You give it a dedicated research prompt. You say, read these specific files and explain how the user authentication flow works.
And the output of this isn't code.
Right, it's a markdown file. It lists file names, exact line numbers, data flow diagrams.
So it's like a map of the territory.
It's a map. And here's the absolutely critical part. You, the human being, sit down and read the map. If the map is wrong, if it says login logic is in auth. But you know for a fact it's in user.ts, you throw the output away.
You don't try to correct it in the chat.
No. You correct the initial prompt and run it again. You do not let that hallucination survive in the context window.
That's the entropy reduction in action right there. You are actively filtering the noise before it ever becomes a coding instruction.
Exactly. You are verifying the premise.
Right.
Then you move to step 2, which is plan. You tell the AI, okay, based on this verified research map, tell me exactly what files you are going to change, what functions you are going to modify, and how we are going to verify that it works.
And again, the output is a markdown file, a spec, not code.
A detailed plan, not code.
And I assume we have to read that too.
You must read it. This is the crucial shift in behavior. Dex mentions that he completely stopped reading the 2,000 lines of generated code and started exclusively reading the 200 lines of the plan.
Because if the plan is flawed, the code is doomed.
Exactly. If the plan is solid, the code is usually solid. If the plan is vague or misses a core requirement, the code will be buggy.
And then step 3 is implement.
Yes. Only then do you let it generate syntax. And here is where the compaction part really comes in. As you move through these steps, you are constantly updating a file called progress.md.
Progress.md, simple enough.
It's a foundational artifact. Dex specifically points out that those slash commands like /compact, which a lot of IDE tools have built in, are trash.
Really? Why?
Because you don't want a blind automated LLM summary of your messy conversation. An automated summary will probably include the hallucinations and the arguments. You want a deliberate, structured, human-curated summary that says, what were our overarching goals? What is the current factual status? And what is the immediate next step?
So instead of a scrolling chat log that goes back 50 pages and contains 3 different failed attempts at fixing a bug, you have one single clean file that is the absolute source of truth.
Exactly. And when you start the next prompt, you only feed in progress.md and the specific files you need. You are meticulously engineering the context to be exactly what the model needs and absolutely nothing else.
You're aggressively curating the memory of the agent.
You are essentially wiping its memory of all the failures and mistakes and only feeding it the verified successes.
This feels like it leads directly into the concept of agents. We have this workflow research plan implement, but Barry Zhang over at Anthropic has a very specific definition of what counts as an agent versus just a workflow.
Right. This is a critical distinction because the word agent is being thrown around like confetti in marketing copy right now.
Yeah.
Everyone claims they're building agents.
Oh yeah, every SaaS product is an agent now.
Barry and the team at Anthropic draw the line based on control flow. A workflow is a predefined deterministic path. You chain things together, do step A, check the result, then do step B, then do step C.
Like the research plan implement loop we just discussed?
Exactly. That is actually a workflow. It's highly predictable. You always know what step comes next. The human is defining the path. An agent, in Barry's strict definition, is when the LLM itself decides the control flow.
So the model takes the wheel?
Right. The LLM evaluates the state and says, I need to check the weather, so I will autonomously call the weather API tool. Or I need to look up customer data, so I'll write and execute a SQL query. It loops, it takes actions, and it gets feedback from its environment without you prompting it to. The human isn't driving. The model is routing itself.
And Barry has a pretty strong rule about this, doesn't he?
He does. The don't build agents rule.
Which is pretty ironic coming from a guy at Anthropic, the company building the foundational models that literally power all these agents.
It is deeply ironic, but it's incredibly sound engineering advice. Basically, his premise is, don't build an agent if a simple workflow will do the job. Agents are computationally expensive, they're remarkably hard to control, and they can easily get caught in infinite loops.
Oh yeah, just spinning out.
They can spend $50 of your API credits in 5 minutes, just relentlessly chasing their own tail, trying to parse a weird error message. Workflows, on the other hand, are reliable.
But sometimes you do need an agent. You actually need that flexibility to solve a novel, dynamic problem where you simply don't know the exact steps in advance.
You do. And that is where Mark Vanderjagt and the de Bruijn analysis bring in this brilliant concept of subagents. But we need to be clear, not for role-playing.
Oh, right. So not like you are a grumpy senior system administrator who loves Linux, or you are a pirate poet.
No, absolutely none of that personality fluff. We are talking about spawning subagents strictly for context quarantine.
Context quarantine. I really like the sound of that. It sounds very sanitary.
It goes directly back to the poisoning and distraction problem. Let's say you're coding, and you need to thoroughly search through 100 different files to find a specific variable definition or a hidden dependency. If you do that in your main chat window, you are instantly flooding your context with 100 files of completely irrelevant noise.
Right. And then the model gets distracted and starts trying to import code from files you didn't even want to touch.
Exactly. Your primary context is ruined. So instead, you spawn a subagent. You essentially say, hey, subagent, go look at these 100 files, find the variable, and just tell me the answer.
So the subagent does all the messy work.
It gets its hands dirty. It reads all the irrelevant files, it processes the high-entropy data, and then it returns only the specific clean answer back to the main agent.
It is literally like sending an intern down to the basement library.
That is the perfect analogy. You don't want the intern to bring you the entire stack of dusty books and dump them on your desk.
Yeah.
You want them to read the books down in the basement and bring you the one specific paragraph that actually matters. That keeps your main context, your executive reasoning, brain totally clean and low entropy. It completely separates the messy search logic from the high-level reasoning logic.
This is all starting to sound very disciplined. It's not just chatting anymore. It's real software architecture. And speaking of discipline, Dex Horthy wrote a manifesto called the 12-Factor Agents. Now, for the old-school developers listening, that definitely rings a bell.
Oh yeah, it definitely echoes the 12-factor app methodology for cloud-native applications from Heroku way back in the day.
Which totally changed how we built web apps.
It did. It set the standard. And Dex is trying to do the exact same thing for AI engineering. We obviously can't cover all 12 factors today, but there are a few that hit this context theme really hard.
Which ones really stood out to you?
Factor 3 is a big one. Own your context window. That's essentially what we've been talking about this whole time. You absolutely cannot rely on the framework or the IDE to manage it for you magically. You must meticulously control what goes in and what stays out.
And what about Factor 12?
Factor 12 is the agent as a stateless reducer.
Now unpack that one for me. Stateless reducer. That sounds very academic.
It's a functional programming concept, but it's very practical here. It basically means treating the agent as a simple mathematical loop. Current state plus new event equals new state. The agent doesn't rely on some hidden internal memory or magic background variables. Everything the agent needs to know to make a decision is explicitly provided in the state object passed to it in that exact moment.
So it's totally transparent.
Exactly. This makes it completely debuggable. If an agent does something crazy, you can pause it, look at the exact state object it was handed, and say, the input was wrong right here. We fed it the wrong file.
It brings actual engineering rigor to the vibe coding era.
It really does. And Dex mentioned something about this process that really struck me regarding code review. He said he used to try to review these massive 2,000-line pull requests generated by his AI agent.
Which sounds completely impossible. I mean, my eyes glaze over after reviewing 50 lines of dense code.
It is impossible. You just sort of scroll down, spot check a few variable names, and hope for the best. But once he switched to this spec-first approach, reviewing the plan document instead of the code, he realized that code review isn't actually about checking syntax anymore.
Because the AI is probably better at syntax than we are anyway?
Exactly. It doesn't miss semicolons. Code review in the agent era is for mental alignment.
Mental alignment. I love that term.
It's about checking intent.
Right.
Are we actually building the right thing? If the generated plan says, step 4, I'm going to aggressively delete the user database to save space, you catch it right there in plain English.
Right.
You don't wait until you see the obscure SQL drop command buried on line 1400 of the code block. You catch the flawed intent before it ever becomes a destructive action.
That seems like a fundamental shift in how we work as developers. We're moving all the way up the abstraction ladder. But Adam, I have to play devil's advocate here for a second.
Please do.
Mart Venderyacht brings up a really strong counterpoint in his writing. He talks about the bitter lesson.
Ah, yes. Rich Sutton's famous essay, The Bitter Lesson.
Right. It's this widely held idea that eventually, raw scale, just throwing more compute, vastly bigger models and bigger data sets at a problem, always beats clever human engineering in the long run.
It has historically been very true.
So the question is, are we just wasting our time meticulously crafting these progress.md files and doing all this context engineering? Won't GPT-6 or Claude 4 just have a billion token window and perfect, flawless attention? Won't the hardware inevitably save us from having to care about this?
This is genuinely the great tension in the AI field right now. The scale argument essentially says, just wait, the hardware will solve it, context windows will effectively be infinite, you won't need to compact anything, you won't need to quarantine context, just dump the whole internet in there.
It's a very compelling argument because honestly, laziness is a powerful motivator. I would deeply love to not have to engineer my context.
Everyone would. But Martin and Rooney push back really hard on this inevitability. They point to the lost in the middle phenomenon.
Which is what?
It's the documented fact that even if the context window is technically huge, say 1 million tokens, the model's attention still severely degrades. It pays close attention to the very beginning of the prompt and the very end of the prompt, but it tends to completely forget or hallucinate over the mushy middle.
It's like me during a really long, boring movie. I remember the opening scene, I remember the end credits, but the entire second act is just a total blur.
Exactly like that. And Mart uses a really brilliant analogy to drive this home. He points to the human brain.
Go on.
Think about it from an evolutionary perspective.
Yeah.
The human brain has been evolving for millions of years. It is arguably the most sophisticated general intelligence engine we know of. Did it evolve to have an infinite working memory? Can you remember 1,000 random numbers if I just read them to you right now?
I can barely remember my own phone number half the time, let alone 1,000 number.
Right. The brain did not solve the problem of intelligence by simply building a vastly bigger hard drive.
That's a great point.
It evolved highly sophisticated selective attention and chunking mechanisms. We learned how to ignore the noise and focus only on the signal. We learned how to summarize complex events. We learned how to deliberately forget useless information. Mart argues that we need to actively mimic that architecture for AI. We shouldn't just lazily try to build a bigger context window. We need to build much better selective attention mechanisms.
So context engineering isn't just a temporary hack until NVIDIA ships better chips. It's actually the fundamental blueprint for how advanced, reliable intelligence works.
That is the core argument.
Yeah.
And honestly, looking at how much better these compacted, engineered workflows perform in the real world, I'm highly inclined to agree. Even if you have a super intelligent model, giving it a clean, highly precise plan will always yield better, safer results than just throwing a whole library at it and saying good luck.
That is a fascinating perspective. Now, Mart also makes a practical distinction between tooling side and human side context engineering. What is the difference there?
This is really important for deciding where you should actually spend your time and energy. Tooling side context engineering is stuff like RAG retrieval augmented generation, or vectorizing and indexing your massive code base. Your IDE, whether that's Cursor or Windsurf or whatever, should handle that completely invisibly. You shouldn't be manually copying and pasting file contents anymore.
Right, let the robots do the grunt work.
Yes. But human-side context engineering is where you, the developer, actually provide unique value. This boils down to rules, commands, and hooks.
Okay, let's break those down. What are rules?
Rules are for your organizational policies. Things like we always use strict TypeScript interfaces, never lose types, or we always use Tailwind for our CSS styling. These are architectural decisions the model cannot possibly guess just from looking at the raw code. You have to explicitly inject them into the context.
Makes sense. And commands.
Commands are for named intent, like configuring a command that says /refactor and having that trigger a specific repeatable multi-step workflow in your code base, rather than you just typing please fix this code and hoping for the best.
And hooks. You mentioned hooks.
Hooks are the most fascinating part to me. These are deterministic guardrails.
Deterministic meaning they never fail, They aren't AI.
Exactly. Meaning they're traditional hard-coded scripts, not probabilistic AI. A hook might be a Python script that runs on every output and says, if there's a text string that looks remotely like an AWS ABI key in this proposed commit, block it immediately. Do not pass go.
So you don't politely ask the AI, please don't commit our security keys?
You absolutely do not negotiate with security. That is human-side engineering.
Yeah.
You don't ask the AI to be safe. You build the concrete walls that the AI is forced to play inside.
Okay, this is all fantastic theory, but I want to really try this. Let's say I'm listening to this deep dive right now. I'm totally fired up. What do I do tomorrow morning? What is the practical Monday morning application of all this?
Let's look closely at the BAML case study from Dex Horthy, because honestly, this is the gold standard for me right now.
This is the one where they fixed the massive Rust code base.
Yes. So Dex and his colleague, Vanam, sat down to fix a really gnarly bug in a 300,000-line Rust code base. Now, an important detail here to set the stage. Neither of them were actually expert Rust developers.
Which is usually a total recipe for disaster. Plunging into 300,000 lines of a language you don't know well, that's how you break production.
Oh yeah, normally it would be a nightmare. But they strictly used the protocol. First step, don't chat. They made a hard rule to completely stop treating the AI like a conversational chatbot. No casual conversation. No, tell me a joke.
Rule number 1, stop chatting.
Rule number 1, second step, research first. They ran a highly specific research prompt to aggressively map out the relevant files for this bug.
And then they read the summary.
They read the summary meticulously. If the AI said, I think the bug originates in file X, and based on their high-level understanding that didn't make logical sense, they threw the output out and refined the research prompt until the map was perfect.
They curated the context before ever moving forward.
Precisely. Third step. Plan second, they had the AI write a deeply detailed implementation plan in Markdown. Something like, I will change this specific function signature on line 40, and then I will add this specific unit test case to verify it.
And this is where they caught the inevitable errors.
This is the magic moment. Dex pointed out that a bad line of research leads to 1,000 bad lines of code. By catching a fundamental misunderstanding in the plan phase, they saved hours, maybe days, of debugging. They just iterated on the text plan until it was functionally perfect.
And then finally implement.
Then they finally let it write the syntax. They fixed the core bug in 1 hour.
Wow.
But here is the real kicker. Later on, they used this exact same rigorous process to ship 35,000 lines of code, specifically adding complex WebAssembly support in just 7 hours.
35,000 lines in 7 hours. That is absurd speed. That is literally months of work for a normal engineering team.
It is staggering. But it wasn't random vibe coding. It was highly structured, deeply engineered speed. It was a factory assembly line, not an artist's studio.
So for the engineering managers and team leaders listening right now, what is their big takeaway from this?
Stop reviewing syntax. Start reviewing plans. Use the AI-generated specs as your primary source of documentation for the team. It keeps everyone totally on the same page, that mental alignment we talked about, without forcing your expensive senior engineers to painstakingly read every single line of generated boilerplate.
I love that framing. It really elevates the human developer to the role of an architect.
It really does. You become the conductor of the orchestra, not the trumpet player. You are defining the music, you are setting the tempo, but you aren't the one physically blowing into the brass.
Let's bring it all home, Adam. We have covered a massive amount of ground today. From thermodynamics and entropy, to Pokemon hallucinations, to rewriting Rust code bases. Let's distill this down. What are the core pillars we need to remember?
Okay, let's recap the big ones. Number 1, context engineering is entropy reduction. Your primary job is to take messy, ambiguous human intent and compress it into clean, machine-understandable input. Number 2, context is incredibly fragile. It poisons easily. It gets distracted constantly. You must treat it like a scarce, valuable resource, even if your API provider gives you a 2 million OKIN window.
The mansion is haunted.
The mansion is absolutely haunted. Number 3, compaction is king. Stop shouting at the AI. Use the structured research, plan, implement loop. Keep your context utilization hovering around 40 to 60%, and rely on a curated progress.md file, not automated summaries.
And what about the agents?
Right. Number 4, agents strictly need boundaries. Use limited sub-agents to quarantine messy tasks, like searching massive file directories, so they don't pollute your main executive reasoning brain.
And the final one.
Number 5, invest heavily in human-side context. Build the strict rules and the deterministic hooks that perfectly encode your specific domain knowledge. Do not lazily rely on the model to just magically know your business logic.
That is a incredibly powerful toolkit. But Adam, you hinted at something a little bit earlier. We've talked extensively about the context today, how we manage it, how we protect it. But what happens when we let these highly capable agents completely loose? When they start autonomously calling each other?
That is exactly the next frontier. We barely hinted at it with the subagents, but we are just scratching the surface of what's coming. Next time, we are going to do a deep dive into agentic engineering practices.
Oh boy.
We are talking about
What?
how do you practically debug a massive swarm of 50 agents all talking to each other? How do you reliably test non-deterministic probabilistic behavior? And critically, how do you use those deterministic hooks to completely stop an autonomous agent from accidentally deleting your production database because it thought it was just optimizing your cloud storage?
That sounds honestly terrifying.
And incredibly exciting.
Mostly terrifying, if I'm being honest, but I genuinely can't wait to get into it. We covered a massive amount of ground today, and we want to specifically thank the original sources that made this deep dive possible.
Huge shout out to Sean Grove for the specs as code concept. That really beautifully framed our entire discussion today.
And Andrzej Karpathy for his incredible insights on context windows and how to pack them correctly.
Barry Zhang from Anthropic for really clarifying the agent frameworks and drawing that strict line between deterministic workflows and autonomous agents.
And of course, Dex Worthy from Human Layer for outlining the practical workflows, sharing that crazy BAML case study, and writing the 12-factor agent manifesto.
And thank you to Mart van der Jaagt and the team at De Brunig for the critical, clear-eyed analysis on exactly why and how long contexts fail.
And finally, a huge thank you to you, the listener, for sticking with us on this deep dive. Let us know down in the comments, are you still a vibe coder or are you ready to be a context engineer?
Be honest.
We
We will definitely know if you're lying.
will see you in the next one.
Goodbye.